Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Intensity and Visibility of PSO-Based Waveguide Arrays, with an overview of existing schemes and technologies for multi-beam combination. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. I'm Deepak. Today I'm here to present you one of the unique research area where we are developing the multiple laser beam combiner. For this we have used the optimization algorithms to automate the process. So this is for the waveguide selection. So before moving to this video, let's talk about that what we will cover into this. In this video, we will initially talk about in which application areas this technology can be implemented and how it is useful. Then we will discuss about the code, whatever we have designed, how to execute it, what are the software and library requirements for it. Then we will talk about what people are doing currently these days and what are the problem identified with them and how our proposed system is handling those problems. Finally, the experimental outcomes and results will be reviewed. So let's start with the application area. As the application is the laser beam combiner, so this is very much popular in the telescopic interferometer. So the application that we have designed is also specifically for the telescopic interferometry, where beams are combining by selecting the different wave guides, right? So in the telescopic interferometer, in the lidar systems, where light detection and ranging can be done by using the laser beams, because obviously the laser beams can be combined in order to get the better results. In the domain of the laser shows, where the lasers are being used to present a show and to combine multiple laser lights to get the better outcomes. Finally, biomedical imaging, for the 3D biomedical imaging and all, where the laser operations can be useful. So these domains are very much unique, and many of the rare people are working for the research work or the designing such practical systems. So the code that we have designed for it is basically designed in the MATLAB. So the folder that we will provide you to run it will be having two folders. One is in which we are doing the analysis for 3 different optimization algorithms with different waveguide combinations. So the waveguide combination that we are using is 2x2, 3x3, 4x4. So these 3 combinations are here that we are using. So we have implemented the system with initially with introducing the concept of PSO, then GSA and FA. So then overall comparison with the traditional systems is also being done into it. So we do have these 2 codes. So in order to run this code, we must have the MATLAB software with us. The MATLAB version that we are using here is 2019. So you can use 2015 or above, but it should be a full version. So what you need to do is in order to run the code, for example, if you want to run for the PSO code, it is having all the files with you. You just need to copy this path and go to the MATLAB and paste it here, Control V and press enter. You can see you are getting the files over here. So these are the 3 files that you need to run. First is for the combination of 2x2, second is for 3x3, and last one is for 4x4. So under 2x2 combination, the waveguides are of 2x2 grid. So in order to run this code, you just need to run this code here, and when you will click enter, it will ask for the wavelength. So wavelength is in micrometer, so you can give the values as per your requirements. So as we are following one of the papers, so we are taking the values from that 850 micrometer. So when I press enter, you can see the simulation has been started for the number of iterations, and the results will be represented in the different scenarios in terms of like metrics at the wavelength achieved, intensity that we have achieved, visibility V2PM, that is asked as V2PM, and at which phase angle it is achieved. So this gives us that which waveguides are out of 2 cross 2, means total of the 4 waveguides are there, which waveguides we need to select in order to combine the laser so that the maximum wavelength, maximum visibility and highest intensity can be achieved, and at which phase the signal will be there. So these are the light waves that we have achieved from the simulation. So this is for 2 by 2. So this is how the code can be run for 3 by 3 and 4 by 4 and so on. You just need to rerun it again you need to just give the values, and then you can get the outcomes in terms of the different parameters. So this is for 2 by 2 for the PSO, 3 by 3 for the PSO, 4 by 4 for the PSO. We do have the another scenarios also, as you can see. Other than the PSO, we do have the GSA also. So we have designed the whole code for the PSO, GSA also. So here you can see, as I was running initially for PSO, now it is for the GSA. So we just need to run it again. We need to give the values so that we can. Here I just entered the 850. I want to enter 850. Press enter, and then we will analyze that which of the scenario, either PSO, GSA or FA, gives us the better outcomes. So I'm running it again. 850. So here you can see the value of the visibility that we are getting through the GSA is higher, and the intensity is also higher. So this system is giving the better results in comparison to the PSO. So now this is how the code is to be run. Let's see that what exactly the current systems were. These are the few of the base paper that we can share with you, in which we are following like discrete beam combiner, DBC, and exploring that it is specifically for the interferometry, which I already told for the telescopic interferometry, in which we do have the setup like this, in which there are number of telescopic arrays, and those are putting their light over the waveguides, where through the waveguides the light patterns are sent to the excitation patterns. Now the challenge was like in these discrete beam combiners, here the number of waveguides are there. Here you can see 3 cross 3, means a total number of 9 waveguides are there. So which of the waveguides will give us the better outcomes in terms of the visibility of the pattern that we are looking from the telescope, those we need to select. Here in the previous systems, the people are doing like selecting the waveguides by their own, by the manual processes, or making the combinations. So but that is feasible for the smaller array size. But when the array sizes are increasing, like let's say it is 4 by 4, it means the total of the 16 waveguides there, which best three waveguide combination is to be selected so that we can get the better visibility and other factors. That was the challenge. So inspired from this problem, we have proposed one of the technique that we will automate the process. To automate the process, we have introduced the concept of optimization algorithms. Now let's see that what exactly the optimization algorithms are. Optimization algorithms are basically the field in which there are certain categories like heuristic, meta heuristic approaches. Those gives us to find a best solution in order to achieve the fittest value, the fitness. Here the fitness is to get the highest output at the patterns, and the visibility at the patterns, intensity at the pattern. So those are the objective function basically. So in order to achieve the objective function, we do have the optimization algorithm. So we have introduced the concept of doing the manual part through the optimization algorithm. So through these laser sources, when we got the output, here the microscopic output is to be connected at the DBC, which waveguides are to be selected is done by the optimization algorithm. So initially we have introduced the one of the oldest optimization algorithm, that is PSO, in order to see that whether the optimization algorithm will be successful in achieving the better outcomes or not. So the PSO optimization algorithm was with that theme, that whether by using the optimization algorithm it can be achieved or not. So when we have implemented that, we got that it is achieving a good outcomes and with the requirement fulfillment of our system. Then we have analyzed some latest optimization algorithm like GSA gravitational search algorithm, and last of the algorithm was Firefly optimization algorithm. So we have implemented for that also. So you can see if I'm running for the Firefly with the same configuration, we do have the results with us. And finally we did the analysis that whether which of the system is giving us the better outcomes. Might be there is index position logical. You can see here I'm running this 850. It will process for number of iterations and giving the results in term of this, right? So this is how we were getting the results, and results are being saved at the end with their minimum and maximum SNR value, so that we can compare it later on. So you can see these files have been saved with the combination set. So finally, after running all the codes with a different configuration, we have compared them with the traditional one. Those traditional one have been achieved with the, for example, here you can see for 2 by 2, 2 by 2 with the 3 different configurations. Then these are for FA results for the 4 scenarios, and then this is for GSA. These are the SNR outcomes. So when I'm running the results for 2 by 2, you will get the outcomes in terms of the factors. Like here you can see we do have the scores where you can see the normalized intensity achieved from the 3 different parameters with respect to wavelength. So we did the variation in the wavelength like 3.1, 3.1. I was running for 850, so it is 3.1, 3.15, because the base paper that we were following having the same configuration in order to get the results, so that we can compare them with it. So here you can see in one of the paper like 2 by 2, we are talking about 2 by 2. So here you can see for the different wavelengths they have analyzed the outcomes. Like here the graph is there, 3.1, 3.2, 3.3, 3.4 and so on. So we have run the simulation for different wavelengths and get the normalized intensity. Secondly, we have also analyzed that with respect to that, the total, the bar, the cross, the PSO, these were the traditional methods, those were given in this paper. So the results are taken from into it, and then the proposed our methodologies, that is PSO based, FA based and GSA, has been implemented in order to show that we are getting the higher intensity in comparison to the traditional method, that gives us the superiority over the manual methods. So by taking this objective we have implemented it. So in order to run this code, the wavelength variations has been given, and you can enter the wavelength as per the requirement. So initially these factors has been taken, that what will be the screen distance, what will be the reflectivity and the refractivity indexes, along with that the window size of the on which the pattern is to be there, then what will be the parameters related to the beam that is focusing on the waveguides, those information is to be given. Then the wavelength per nanometer has been entered by the user in order to get the outcomes. All these calculations has been made, and finally by using the optimization algorithm, here we are getting the best waveguide set to get the highest intensity, more visibility, and at what phase the light will be there, right? So this is to be calculated with the different different algorithms. So further modifications are still possible into it. Even we have a few more video related to this, in which higher order configuration is also analyzed, like as in this we have done for 2 by 2, 3 by 3 and 4 by 4. The furthers are for the higher configuration like 8 by 8, 9 by 9. So for more details you can contact us directly and can get the details. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.